So in this video, we're going to go over the problems that are in the Unit 5 test review. So this first question, it says, Kara is observing the growth of a population of bacteria. She started out with 550 bacteria cells. The population of bacteria doubles every hour. Use X to represent the number of hours and Y to represent the population of bacteria. Write an equation that correctly represents the scenario. So it's very important to use this exponential functions formula sheet that's linked in your resource folder. It has all the equations that we talked about in this entire unit. So notice here it says when you have words like double, triple, halved, etc., and you have the rate of change can be represented as a number, you want to use this exponential growth or decay formula. So we're going to use this y equals a times b to the x. So a represents the initial amount. So here it says she starts off with 550 bacteria, so a is going to be 550. B is the rate of change. So if the bacteria are doubling every hour, that means B equals 2. So we can write this as y equals 550 times 2 to the x power, okay? Because it's x is representing the number of hours. So we can write this as 550 times 2 to the x. Okay, so here it says $12,000 is deposited into a savings account with an annual interest rate of 3% compounded continuously. How much money will be in the account after 4 years? So the very important key word here is continuously, right? Whenever we have something continuous, we're going to use the formula that involves E. So here in our formula chart, it tells us that P is the initial value. So that is going to be that $12,000. E is that constant, right? It's Euler's number. And then we have R is 3%. And we just need to convert that to a decimal. So that's going to be 0.03. And then T is the value of time. So T is equal to 4. So if we plug everything in, we have A equals 12,000. And then we have E to the 0.03 times 4, right? Because it's R times T. And actually what we can do is we can go ahead and enter this in our calculator exactly as I've written it. So we can do 12,000. I'm going to type E from my keyboard, and then I do exponent, and then parentheses 0.03 times 4. Okay, so then when you hit enter, we're going to round to the hundredths place because we're talking about dollars and cents, right? So this is going to be $13,529.96. So in this problem, it says the driver buys a used car for $15,389. The value of the car depreciates by 10%. What is the value of the car after 3 years? So the key word here is depreciates by 10%. So if we go to our formula chart, you can see we have not continuous, but it says we have a percentage, and then depreciates tells us that it's decreasing. So we're going to use the exponential decay formula, which is y equals a times 1 minus r to the t. So remember, the value of A is the starting value. So we have 15,389. And then R is the percent, right? So that 10%, we're going to go ahead and convert it to a decimal by moving it to the left 2 places. So that's 0.10. T is the value of time. So here it tells us 3 years. So now we just go ahead and plug everything into this formula that we have. So we have Y equals 15,389 times 1 minus 0.10, and that's to the t, which is 3. So now let's go ahead and go to our calculator, and we can type this in exactly as we've written it. So we have 15,389 times 1 minus 0.10, and that's all being raised to the third power. So when we hit enter, we can get the value of the car after 3 years. So that is going to be $11,218.58. Okay, so that's going to be the value of the car after 3 years. Okay, so here we have a different sort of problem. It says we have 5 to the 3x equals 125 to the 2x minus 4. Remember, the goal in these kind of problems is that we want to have the same base on either side. So in order to help us out, I'm going to use this powers chart. Okay, so you can see on the left side, we have a power of 5. And if we look at our chart, you can notice that 125 is a power of 5, right? So you can see that 5 to the third is 125. So I'm going to use that to rewrite this problem. I have 5 to the 3x equals 5 to the third, but then that's being raised to the 2x minus 4 power. Remember, our power of a power property tells us that if we have a to the m raised to the n power, that's going to be a to the m times n, right? We multiply the exponents together. So since we have 5 to the third to the 2x minus 4, we're going to do 3 times 2x minus 4, which means we're going to distribute that 3, and that's going to give us 6x minus 12. So we have 5 to the 3x equals 5 to the 6x minus 12. And so now that we have the same base, we can set the exponents equal to each other. So we set the exponents equal. We have 3x equals 6x minus 12. And now we're just going to go ahead and solve for x. So we can do that by gathering all our variables on one side. So we're going to subtract 6x from both sides, which gives us negative 3x equals negative 12. We're going to go ahead and divide by negative 3, which gives us x equals 4, and that's the solution to this equation. So now here we have another exponential equation, but notice we already have the same base. If you already have the same base, all you need to do is go ahead and set the exponents equal to each other. So we have 2x minus 5 equals x plus 2. I'm going to start off by subtracting x from both sides so I can gather all my variables. 2x minus x is x, so we have x minus 5 equals 2. And then now I can solve for x by adding 5 to both sides. So when I add 5 to both sides, that's going to tell me that x equals 7. And that is my solution. Okay, so here in this problem, it says Michael invested $74,000 in an account paying an interest rate of 2% compounded quarterly. Assuming no deposits or withdrawals are made, how much money to the nearest cent would be in the account after 10 years? So I'm going to go back to our formula chart. We have compound interest, right? So compound interest means we have to use this formula. And remember, since it says compounded quarterly, that's going to tell us some information that we need. So A is the initial amount, right? So he starts off with $74,000. So A is going to be 74,000. R is going to be the percent interest rate, right? So that 2%, I'm going to go ahead and change that to a decimal. So that's going to be 0.02. N is going to be depending on the compounding schedule, right? So compounded quarterly, we can see here it says quarterly means N equals 4. So we have N equals 4, and then we need our value of T. Well, it tells us how much in the account after 10 years. So let's go ahead and plug all these values back into our formula. So we have Y equals 74,000 times 1 plus 0.02 over 4. And that's being raised to the 4 times 10 power. Okay, so actually we can go ahead and type this into our calculator just as I've written it. So I'm going to go to the Desmos calculator. And once I clear this, I have 74,000 and then parentheses 1 plus 0.02 and then use the divide to put it over 4. Okay, and then I'm going to click here and then close this parentheses. Then I have exponent, and then I'm going to do 4 times 10. Okay, but I need to put that 4 times 10 in parentheses so that it all stays in the exponent. If you want to go ahead and multiply it and just change that into a 40, you can do that also. So 4 times 10, if you're doing it as 4 times 10, make sure that it's in parentheses so it all stays in the exponent. So when you hit enter, it gives you the value. So we have $90,338 and we have 77 cents. Okay, so that's going to be how much money is in the account after 10 years. So here it says a town has a population of 12,000 and grows at a rate of 3% every year. What will be the population after 7 years to the nearest whole number? Okay, so we have a growth formula, and so we need to go to exponential growth. So we have y equals a times 1 plus r to the t. And let's figure out the values we have. The starting value a is 12,000. R is the rate of change, so 3%. I changed to a decimal by moving it to the left 2, so that gives me 0.03. T is the value of time, which tells me 7 years. So we're going to go ahead and plug everything in. We have y equals 12,000 times 1 plus 0.03, and that's to the 7th power. So that's going to be y equals, and then once again, I'm going to go to my calculator, and so I have 12,000 parentheses 1 plus 0.03, then close the parentheses. I'm going to do exponent and then 7. And when I hit enter, remember I want to round to the nearest whole number because I'm talking about people, so I don't want any decimals or fractions. So this is going to be 14,758 people. Okay, so I'm just going to round that to the nearest whole number like that. Okay, so in this next problem, it says Maggie's in a chess tournament. The tournament has 275 teams, and after each round, a quarter of the teams are eliminated. Write an equation that can be used to identify the number of teams that will remain after X rounds of games. Okay, so we need to figure out the formula we need. So it says like the rate of change is kind of given to us as a number, right? So it says a quarter is eliminated. So that's kind of like when we have double, half, triple, etc. So we're going to use that y equals a times b to the x. So a is the initial value, that 275. So we have y equals 275. A quarter means 1/4, right? So we're going to do b is 1/4, and then we just do that's to the x power. Okay, so all we need to do is write the formula. We're not actually solving for anything in this problem. So we have y equals 275 times 1/4 to the x. Okay, so here it says scientists have found that the population of mice in a certain area has increased by 23% each year since 2020. The initial mouse population is 575. Write a function that can be used to identify the number of mice in the population X years after 2020. So it has a percentage, right? And it tells us that it's increasing. So if we have a percentage and we see increasing, that means we use the exponential growth formula. So we have y equals a times 1 plus r to the t, right? A is the initial value, so 575. R is that percent rate of change, so it tells us 23%. And I'm going to go ahead and change that to a decimal, so I have 0.23. T, well, we don't have T in this problem, right? So it tells us that we're using X instead of time. So X is the value of T. So we're going to write this as Y equals A, which is 575 times 1 plus 0.23. And then instead of T, we're going to call that X. Well, that 1 plus 0.23, we're not going to leave it like that. We don't want to write 1 plus 0.23. We'll just go ahead and write it as 1.23. Okay, so here it says a student bought a new computer for $800. Its value will decrease by 9% each year. Write a function that represents the value of the computer, y, after x years. So we have a percentage and then it tells us decreasing. So we're going to use exponential decay. We have y equals a times 1 minus r, and that's to the t. A is 800. That's the initial value of the computer. R is 9%, right? We're going to go ahead and convert it to a decimal. So that's going to be 0.09. And then t, well, once again, they want us to call t x. So we're just going to replace it with x. So when we write the formula, we have y equals 800 times 1 minus 0.09, and that's to the x power. That 1 minus 0.09, I'm not going to leave it like that. If you want, you can go to Desmos, and it'll give you a value. So you do 1 minus 0.09, and it tells you that you have 0.91. Okay, so we're just going to rewrite that as 0.91 so it looks a little neater. And so we have 800 times 0.91 to the x.